Math 1, Unit 9, Perimeter and Area. 9.4 worksheets show all your work to receive full credit, and today we're going to do most of it, or a good chunk of it, on a separate sheet of paper. Alright, number 1, number 1 through 3, determine whether triangle ABC is scalene, isosceles, or equilateral. Explain. Okay, first of all, we need to make sure we all remember what scalene, isosceles, and equilateral mean. What is scalene? Scalene, all three sides of the triangle are of different length. Okay, they're all different. Isosceles, anybody remember isosceles? Isosceles, two of the three sides are congruent. And finally, hopefully equilateral, it's all in the name. Equal sides, equilateral. All three sides are congruent, the same length. So we're going to have to determine these three triangles if they're scalene, all three sides are of different length, isosceles, two of the three are the same, or equilateral, all three are the same. Okay, to start, determine the vertices of the triangle, then use the distance formula to find the length of each side. Alright, so it looks like they give us a little help here. First, A is at negative 1, 1. We might want to define the axis, right here, the X and Y axis, because I have trouble seeing them sometimes and I get confused. Alright, so we can hopefully see that A is at negative 1, negative 1. B is at 1, 2, 3, 1. And C looks like is at 1, negative 1, negative 2, negative 3. So that's the first thing we want to do is fill in the missing vertice. Alright, now we have to use the distance formula 3 times to prove whether this is scalene, isosceles, or equilateral. Right off the bat, I'm guessing it's isosceles. It looks like A and B and C and B are congruent. But we're going to have to do the work to find it out. So, we'll bring in my paper here. And hopefully you remember we talked about this on our first unit in geometry. When we write AB like that, if we put a line over it with arrows, it means line AB. If we put a line over it with one arrow, it means ray AB. If we put just a line over it with no arrows, it means line segment AB. And when we put nothing over the top, it means the length of AB. So if we want to find the length of AB, we will use the distance formula. Okay? So remember, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay? Now still some of you are sitting there going, I'm not going to write that part. That's dumb. Why waste the time? Okay? That is your decision, but I'm telling you, kids who take the time to do that never fail to succeed. Alright. So I'm going to simply call this x1, y1 and x2, y2. That'll help me with plugging in the information. So AB equals the square root of 3 minus negative 1 squared plus 1 minus negative 1 squared. Means AB, the length of AB equals the square root of, we have to add the opposite, so this becomes 3 plus 1, or 4, squared plus, add the opposite, and it becomes 1 plus 1, or 2 squared. And AB equals the square root of 16 plus 4, which means AB equals the square root of 20. I got to go back and see how they ask us to leave this. Find the length of each side. So we don't actually want to round this off. Okay? So we do want to remember that 20 is actually 2 times 2 times 5. And you've really, if you want to be a successful math student, you've got to get good at simplifying square roots. Remember, it's a square root, so it takes 2 to get 1 out. So a 2 is going to get out, and we get the, I forgot my b. AB, or the length of AB, equals 2 root 5. Okay, I have a suspicion that BC is going to be the same length. Okay, so I'm going to find the length of BC right now. So I'm going to do it right here. BC equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, well, I'll leave, I guess I'll leave b as x2, y2, and I'll make this guy x1, y1. So this time it's going to be BC equals the square root of 3 minus 1 squared plus 1 minus negative 3 squared. Am I going too fast? So we're looking for the length of BC, and it equals the square root of 3 minus 1 is 2 squared plus, add the opposite, and we get 1 plus 3, which is 4 squared. And hopefully you can see these guys are going to be congruent, aren't they? Because from here on out, all the steps are the same. Even though we started out a little bit different, right here, you can already tell that they're going to be congruent. So we'll just continue on. BC equals the square root of 4 plus 16. BC equals the square root of 20, and we already know the answer. BC equals 2 root 5. So they are congruent. Okay? But we still got to find the third side, because even though it doesn't look like it, we can't assume anything. So we have to find the length of CA right now. That's that side right there. All right, so it won't be on the camera here, but we can look up and see that the length of AC equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which means AC equals the square root. Well, I'm going to have to change one of those to x2. So let's change C to x2 and y2. So now we have the square root of 1 minus negative 1 squared plus, what did I do? Negative 3 minus negative 1 squared. So we get AC equals the square root of, okay, first we have 1 minus negative 1. We add the opposite, and we get 2 squared. Plus, we have negative 3. We add the opposite, and we get negative 3 plus 1, or negative 2 squared, which means AC equals the square root of 2 squared, which is 4, and negative 2 squared is 4 as well. So we get AC equals the square root of 8. Remember, 8 is 2 times 2 times 2, which means a 2 gets out, a 2 gets killed, and a 2 stays in. So the length of AC is 2 root 2. So we can go back to our paper here and say this is definitely an isosceles triangle. Okay? And how do we know? Two sides are congruent. Okay? Questions on that? Did that take a few minutes? Sure it did. Was it that difficult? Not once you know the distance formula and you take your time and plug everything in carefully. All right, so I'm going to leave 1 and 2 for you to do. All right, those are same thing, except you have to discover A, B, and C on your own. I'll help you with number 2's A, B, and C. A is at, on these, I always think it's a good idea to identify your axes because, I don't know, for me they're a little hard to see. Alright, so it looks like A is at negative 1, 2, 3, 4, negative 1. B is at, looks like 1, 1, 2, 3, 4. And C is at 1, negative 2. Okay, now, you'll notice that BC is on a vertical axis, so I don't expect you to do the distance formula there. Let's be smart about that. Let's count 1, 2, 3, 4, 5, 6. So we're going to have to find the length of AC, we're going to have to find the length of BC, and the length of CA. But we can count 1, 2, 3, 4, 5, 6. So we know that BC is actually 6. So that saves a little bit of time for you. And it looks like you're still going to be able to do the same thing for BC over here as well. Okay, so let's go on to number 4. This is the last one I'm going to help you with. All right, and it says determine whether the parallelogram is a rhombus, a rectangle, a square, or none. Explain. All right, so before we do that, we have to review the characteristics of a rhombus, a rectangle, a square, or none. First of all, what is a parallelogram? Anybody? What's a parallelogram? Excellent. Parallelogram is a quadrilateral with opposite sides parallel. Parallelogram. That's why we call it a parallelogram, because the opposite sides are parallel. Okay? Now we know a lot of other things about a parallelogram, but we can stop there for right now. What is a rhombus? Anybody? Okay. A rhombus is a parallelogram with 4 congruent sides. Okay, so a rhombus is just a parallelogram with 4 congruent sides. How about a rectangle? What's a rectangle? Ah, you guys bring me so much pride. A rectangle is a parallelogram with 4 right angles. Now we know a lot of other things about all of these guys, but for right now all we're focusing on is the specifics. And finally, a square, we can really go either way. But a square is a parallelogram with 4 congruent sides and 4 right angles. Okay, now we spent a lot of time on this next part last semester. So our job today is to discover if these guys first are parallelograms, and then more specifically what type of parallelograms they are. So parallel lines are probably going to be important, right? Okay, so how do we know if two lines are parallel when we are on the coordinate plane here? When we're using the coordinate plane, or more specifically up here on number 4, how do we know on the coordinate plane if two lines are parallel? I hope you guys are just bashful today. All right? Parallel lines. Here we go. Parallel lines have, excellent, the same slope. Parallel lines have the same slope. Okay? All right. Now, that'll help us determine parallelograms, because if we compare the slopes of the opposite sides, we should be able to determine if they're the same. Then yeah, this is a parallelogram. But we also want to know about rhombus. So rhombus, all 4 sides are congruent, right? That's where the distance formula comes in. All right. Rectangles have 4 right angles. How do we determine if, on the coordinate plane, how do we determine if two lines or line segments are at a right angle to each other? It's another word for right angle. Perpendicular. Excellent. Excellent. Perpendicular. Very good. And perpendicular. How do we determine if two lines or line segments are perpendicular on the coordinate plane? Ah, that's awesome. Okay. Perpendicular lines have opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes. So let's write the examples of a few things that are opposite reciprocals. So for instance, 2/3, the opposite reciprocal of 2/3 would be negative. That's where the opposite comes in. If this positive, that's negative. That's the opposite. And reciprocal is, I like to sometimes say, refliprical. Refliprical helps. You flip it. 2/3 becomes 3/2. All right? If we had, say, -5, the opposite reciprocal of that would be, first, negative. The opposite of negative would be positive, and the reciprocal of 5 is 1/5. Okay? And what is the reciprocal of 0? Well, the opposite reciprocal of 0 is just 0. Okay? We can't really have an opposite reciprocal of that. But let's think of it in a different way. What if we had the 0 over 5? We could get a slope of 0 over 5. So what would be the opposite reciprocal of 0 over 5? Well, it would be -5 over 0, wouldn't it? But when we talk about that, we can't have 0 as a denominator. So when we're in the coordinate plane, if you have a 0 slope, the opposite reciprocal, or something that is perpendicular to a 0 slope, is a, does anybody know? undefined. If you look over there on that poster, you see I have the 0 slope circled. That's a horizontal line. And right below it is a vertical line, and that's undefined slope. Okay? All right. With all of that in mind, kind of keep that off to the side or remember that. I'm going to do number 4 with you, and I'm going to leave you guys to get to doing the rest. It's going to be hard to do number 4, show you all the work and moving back and forth, but I'll try and move back and forth there. So number 1, we have to first graph it. So A is at -2, 1, -2, -1, so that's A. B is at -3, -3. Okay, C is at 1, -5. And D is at 2, -3. Okay, use a straight edge, connect the dots, like I'm doing. And that's D. All right, so what does that look like to you guys? It looks like a rectangle to me, right? Is that what you guys said? Looks like a rectangle, but we have to find all the lengths and all the slopes to prove it. So, as you can see, we're going to use the slope formula 4 times, and we're going to use the distance formula 4 times. So, yeah, it's going to get a little monotonous, but it's what we have to do today. All right, so let's just go down the list. We'll find the lengths of AB, BC, CD, and DA, and then we'll find the slopes of each, and we'll be able to say what kind of figure this is. So let's start with AB. Now, we really don't need to use the picture. We just need those points right there. So first AB. So AB, again, is square root of x2 minus x1 squared plus y2 minus y1 squared, which means AB equals the square root of -3 minus -2 squared plus -3 minus -1 squared. Okay, I take my time, make sure I get it all plugged in correctly. -3 minus -2, -3 minus -1. Get AB equals the square root of, add the opposite, -3 plus 2 is -1 squared, plus -3 plus 1 is -2 squared. And we get AB equals the square root of -1 squared is 1, and -2 squared is 4. So we get the square root of 5. AB equals the square root of 5. So I'm going to go in, I'm going to put that in there. Okay, and I'm going to go on to BC. Too fast? BC equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which means BC equals the square root of, we're doing BC now, so let's go 1 minus -3 squared plus -5 minus -3 which means BC equals (1 plus 3 is 4 squared plus -5 minus -3. We add the opposite and we get -5 plus 3, which is -2 squared. BC equals the square root of 16 plus 4, which means the BC equals the square root of 20. 20 is 2 times 2 times 5, which means BC equals 2 root 5. Okay, so let's go ahead and write that in. Okay, and on to CD. So the length of CD again is the square root of x2 minus x1 squared plus y2 minus y1 squared. Take your time, do not rush. Neatness counts. CD equals the square root of 2 minus 1 plus 2 minus 1 plus 2 minus 1 squared, I should say, plus negative 3 minus negative 5 squared, which means CD equals the square root of 2 minus 1 is 1 squared plus negative 3 minus negative 5. We add the opposite and we get negative 3 plus 5, or 2 squared, which means CD equals the square root of 1 squared, which is 1, plus 2 squared, which is 4. So we end up with CD equals the square root of 5. So if we go and write that in, CD is equal to the square root of 5. Well, it looks like AB is congruent to CD, right? So now if we find out that BC is congruent to DA, then we've got ourselves a rectangle. Well, at least we've got ourselves a parallelogram for sure. So let's go over to, now we're looking for DA. And the length of DA is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So DA equals the square root of, all right, we're doing DA now, so let's go 2 minus negative 2 squared plus, we went 2 minus negative 2, so negative 3 minus negative 1. So that means DA equals the square root of 2 minus negative 2. We add the opposite and we get 4 squared, plus negative 3 minus negative 1. We add the opposite and we get negative 3 plus 1, which is negative 2 squared, which means DA equals the square root of 16 plus 4, which means DA equals the square root of 20, which means DA equals 2 root 5. And now we can see that BC is congruent to DA. So we got a parallelogram, so that, because there's no way that two opposite sides can be congruent and not parallel. So now we got to determine, is it a right, or we have 4 right angles. Is it just a parallelogram or is it a rectangle? Because we know it's not a rhombus or a square because they don't have congruent sides. So now we're trying to determine, is this thing a rectangle or is it just a parallelogram? And we have to do our slopes now. So we're about a little more than halfway done because the distance formulas are a little more difficult. So let's go back to slope formula. Hopefully you guys remember the slope formula is, I like to say, delta y over delta x, or y2 minus y1 over x2 minus x1. Delta means difference, so the difference in y's over the difference in x's. All right? So we're going to be using the same information we just used. So let's find the slope of AB is negative 3 minus negative 1 over negative 3 minus, oh, no, yeah, I'm right. Negative 3 minus negative 1 over negative 3 minus negative 2. Got to be careful here because we were dealing with x's first and then y's. Now we're dealing with y's and then x's. So you got to be really careful. Make sure you get everything in the right spot. So that means the slope of AB is, we add the opposite and we get negative 3 plus 1, which is negative 2, over, we add the opposite and we get negative 1. A negative over a negative is a positive, so the slope, I'm sorry, you didn't see all that. It was negative 3 minus negative 1 over negative 3 minus negative 2. We added the opposite and we got negative 2 over negative 1, which is just a slope of 2. So AB, the slope is 2. Let's go on to BC now. Find the slope of BC, which is, remember, y2 minus y1 over x2 minus x1, which BC is negative 5 over negative 3, negative 5 over negative 3, I'm sorry, negative 5 minus negative 3 over 1 minus negative 3. Double check, make sure I got those in there correctly, and I did. So we end up with BC equals, we add the opposite, negative 5 plus 3 is negative 2, and 1 plus 3 is 4. So we end up with BC equal to negative 1/2. So I'll plug that in there. Okay, now let's find the slope of CD. The slope of CD is negative 3 minus negative 5 negative 3 minus negative 5 over 2 minus 1, which means the slope of CD is, we add the opposite and we get negative 3 plus 5, which is 2, and we get 2 minus 1, which is 1. So the slope of CD is 2 over 1, or simply 2. So it looks pretty good for a rectangle because the two congruent sides are also parallel. And you'll notice, I didn't mention this before, but we noticed that AB and BC are opposite reciprocals, right? So it looks like BC is perpendicular to both AB and CD. So this is a rectangle, but we need to find the last slope just to make sure. So we'll find the slope of DA, which again, remember, is y2 minus y1 over x2 minus x1. And let's see, that is, we're going to go with negative 3 minus negative 1 over 2 minus negative 1. Now, I finally did this one. I did each section. I normally don't do this. I don't like doing fractions in one line. A lot of you do that, and I wish I hadn't now that I'm looking back. But this paper I have is not college ruled paper, so it's not many lines on a page. Hopefully you guys all have college ruled paper, and it would have taken up a lot more space. But I really think for you guys the best way to do this is when you do your fractions, anytime you have fractions, do your fraction on 2 lines. It's much neater, and it will help you guys stay organized. So finding the slope of DA, we add the opposite and we get negative 3 plus 1, which is negative 2, and we get, add the opposite, we get 2, and I'm seeing I messed up somewhere because, let me go back and check DA again, negative 3 minus negative 1, that's correct. And 2 minus, oh, that's where I messed up. Nope, wait a minute. 2 minus 2, yep, that's where I messed up. It's 2 minus negative 2. And 2 plus 2 is 4. And we get negative 2 over 4, which is negative 1/2. So we put that on there. And we see that these two guys are congruent. But more importantly, in this case, we can see that the consecutive sides are perpendicular to each other. So this is definitely a rectangle, because opposite sides are parallel. That's the form for parallel. And consecutive sides, that means next to each other. The sides next to each other are perpendicular. Okay? Or at right angles. Any questions on that one? That was a lot of work, wasn't it, for one question? Well, you guys are going to go back and do number 2 and 3 on your own. And you're going to do number 5, which is exactly what we just did. Okay? Number 6, all you have to do, it looks like, is find the lengths. And number 7, you have to find the lengths and the slopes again. But you have about an hour to do it. Okay? Almost an hour to do it. That's all we're doing today. So once you're done with that, you'll have done all of the material for this unit. And the only other thing for you to do is we'll do some reviews and get ready for the actual final test. You guys are going to, every time you finish a problem, you are going to come and show either myself, Mr. Chang, or Mr. Montoya your problem. Okay, I would even suggest coming up halfway and showing us your distance formula work and your slope formula work, so we can check you off and make sure you're doing it correctly. We're going to be looking for neatness, organization, and obviously the correct answers. Okay? So you're going to get a bunch of checkoffs. I'm going to say you better have at least 1 initials from each of us for each problem. A minimum of 1 set of initials. So you're going to come and show us. We're going to initial it that you checked it off, and then you're going to go on to the next problem or the next section. Any questions of what you're doing the rest of the period? Okay, ready, break.